Anybody have any talks, questions, or issues for us to talk about to start with? Not today? Okay. Plan on this being a short class today, not a whole hour. So, I plan on it being short today. Okay. Yeah. So we'll just finish this section up and head into the weekends. The plan. Okay. So we don't have too much left in this section. So let's kind of remind ourselves of what we did Wednesday a little bit. I need it. Okay, maybe you don't. I do. Okay. So we have talked about how to write down a set in roster notation so far. So for that we use a capital letter as the name of the set, and then the equal sign, and then curly brackets. Okay. And then we just list out all the members of the set, put a comma in between each one. That's our roster method. We said two sets were equal. Well, it has to be true for two sets to be equal, remember? Yeah, they got to have the exact same elements, the exact same members, however you want to say that. Okay. And then we talked about the cardinal number of sets. And the cardinal number, what's cardinal number mean? Well, you're thinking, yeah, you're getting a little bit ahead. I mean, you're thinking about the right thing. It's just how many elements do we have in the set, right? And then we talked about one more thing. It was the last thing we talked about was we can say two sets are equivalent if they've got the same amount of elements in it. They have the same cardinal number. Okay. All right. So that's the very brief summary. Okay. So the next thing for us to talk about in this section is a different way to write down a set. Okay. So roster notation is pretty straightforward, but when you start getting into very large sets, it takes you a long time to write all the stuff down. And if you're having to write it down over and over, you don't want to have to do that. So we have another way we can write down sets, okay? And that notation we call set builder notation. So the idea with set builder notation is that we're not going to list out all the elements. What we're going to do is we're going to come up with some type of property or some characteristic that all the elements in the set have. And we're going to say this set consists of all the things that have this property. Okay. And we'll be able to talk about the set that way. So let's see. So what we're thinking about, like maybe we want our set to be all the even numbers. We can't even list all those out because we would just list forever. You can always just go to the next number. All right, so instead we would use set builder notation. So let's think about how we would do that one. Okay, we're still going to have a capital letter, uppercase letter, equal sign, and then a curly bracket. Okay. So let's do that. We want to do all even numbers. Okay. So I don't know, we could call it set E maybe for even. We would have our equal sign, and then a curly bracket. Okay. And then what we do, we pick some variable. It doesn't matter what you call it. Usually you'll see X. Okay. We'll say set E is the set of all X's. And then you'll see a vertical line. And the way we read that vertical line is we read that vertical line such that. Oh, Fucking around. That's the vertical line part. And then we state the property that we want all of our set members to have. So we could say set E is the set of all x's such that, and then we could say something like x is an even number. And that would work, okay? Depending on what kind of property we're writing down, there's more like mathematically technical ways you could write some things down. So instead of saying x is an even number, we could say x is of the form 2n, right? We kind of saw that a little bit, and that would be okay. There's actually a symbol we can use for even numbers, okay, that represents even numbers. You can say x is in, and then use that symbol. Okay, we're not gonna worry about that too much, okay? Because words are fine. Okay, words are fine. But that is a lot shorter than having to list out an infinite list of infinite numbers, right? Of even numbers, I mean. Okay, let's try another one here. Well, that's actually the one I just came up with. Let's do, since I messed this up, let's do, no, that's a different list. On the last one, I wasn't technically correct, really, so we'll think about this. So this one says we want to list a set of all even integers. I should have, let me fix the last one, okay? It's going to bug me. Because really what we did there was we did all positive even numbers. And then we should say it's a positive even number here. So this one's just a little bit different because integers, what do you remember about integers? What numbers are integers? They're whole numbers and then positive and negative. Right? Positive and negative whole numbers, okay? And zeros in there as well. Okay. So here it says it wants us to call a set y. So there's y. And we can say this is the set of all x's, and then our vertical line for such that, and then we say our property. Okay, so it's the set of all even integers. So we've got two things we've got to put in there. It's got to be an integer, and it's got to be even. So in words, we could just say both of those things. We could say x is even, and x is an integer. Okay, that would work. We could use words. Okay. There's another way we could do it, because like I said, some of this math-related stuff, we have some more math notation we could throw in. But the set of integers actually has its own symbol. So the symbol for integers is a weird Z. Okay? It's like a Z with a double bar in the middle. Okay? And if I remember correctly, the reason why it's a Z, I think it comes from the German word, okay, for integers there. So that one. So how else could we write it? We could say x is even and x is an integer. with that symbol. So let me see if I've got room here. Nope. I'm gonna write that other one so big I didn't leave myself room. We could say x is even, and x this. I just want to show you this so you'll know what's going on if you see the notation. Okay? So this is a way of saying that a particular value is in a particular set. So it looks kind of like an E, but it's curved. It's an epsilon. That's what it is. Okay, so if you see a little curved looking E, that's saying the thing that comes before that is in the set that you see. Okay? And then Z means the set of integers. Words is okay. You can do it in words. I just want you to kind of have an idea of what's going on if you see things that other way there. Okay? Okay. And we're good on that one. Let's look at the next one here. Okay. So it gives us another set to make. Is we want to set J of all natural numbers less than 10, and it wants us to write it down using both methods. Okay. Natural numbers, what are they? I know they're the counting numbers, the numbers we count with. So start with 1, 1, 2, 3, 4, 5, 6. If you add in 0, that makes that the whole number. If you add in negative numbers, you get the integers. So here, natural numbers less than 10. Okay, so in roster notation, we just list them out. So we want the counting numbers, okay, starting at 1, that are less than 10. So we just list them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's the roster method. And then in set builder notation, we could make the same set, still be set J. Here we'll have the set of all x's such that, yep, the x is a natural number. And what? It's got to be less than 10. It's got to be less than 10. Yeah, so x is a natural number and x is less than 10. There's our set builder notation there. And this part, the natural numbers, okay, just in case you see it, the natural numbers have their own symbol. Okay. It's easier to remember because it's a weird N. And the natural numbers are an N with the 2 bars. Okay. That's kind of sloppy. Let me see. And nope, not doing too good today. Hard to write. They're script letters. Yeah, it's a little better. N. So another way we could say that first part, x is a natural number, is we could say x is a member of the natural numbers. That one was better. Okay. So just, if you see it, this says the same thing as this. Okay. All right. This. All right, so we're good on set builder notation there. Okay. The last couple of things for us to look at, well, I think maybe a couple may be a little optimistic. Let me see. Yeah, we got 2 special sets and then 1 kind of operation we can do with sets we're going to look at when we'll be done. Okay, so we've got 2 special sets we need to talk about. So the first one is called the empty set, or the null set. You can call it the null set. And the empty set is what it sounds like. It's the set that has no elements. It's empty. So the symbol for the empty set, it's up there on the screen, but I just want to show you what mine looks like when I write it down. It's just an O with a slash through it. Okay.
Problem that required that required like answer have no plans out of it, and then I just left it blank and
Well, that's interesting. I don't know why we should. So it should have been the empty set if it was going to mean nothing, right? Should have been the empty set there. I don't know. Have to, if you run back across one like that, screenshot it, send it to me or something. Okay. So the empty set's a little weird in its notation, and this is picky. Okay, set theorist. I'm not a set theorist, so I'm not that picky. Okay, set theorists are real picky about it, and Hawks will count it wrong if you do this notation mistake here. Okay, so the empty set is the only set that does not have curly brackets around it. Okay, so all you have to do is write the little symbol, and that represents the empty set. So if you do this, this starts getting a little mind bending, but what this means with the curly brackets around it is you have a set that has 1 element, 1 member, and the thing that's in the set is the empty set. Okay, so that just to kind of start thinking in circles when you think about that. But so we don't put curly brackets around the empty set if we mean the empty set. Okay. The technicality there, I just want you to be aware of it though. And then the other name, null set, what does null mean? None, or it can even represent a number. What number would null be? 0, yeah, null is another name for 0. So this set just operates like a 0 does, but in sets. Okay? So let's think about a couple things here. Okay? We want to think about if either one of these sets would be empty. So A says the set A of negative numbers less than 100. Would that one be empty? Can you think of any number that would be in there? It's got a lot of numbers in there if you think about it. Because all the negative numbers are less than 100, right? So that one's not empty. Okay, it's weird, but it's not empty. Okay. What about B? This one make you think about geography again. It says a set B of any state that contains the letter Q in its name. Yeah, there's not one. Okay, you can think about it for a little while, but there's not one. Okay, it has the letter Q in its name. So set B here would be empty. Okay? So we could say set B would be the empty set. Okay, the next special set, skip over that. Next special set is called the universal set, or sometimes you'll just hear it called the universe. Okay. The special thing about the universal set is it contains everything. Okay. But that's not quite as straightforward as it sounds because it depends on our situation. Okay. So if we're dealing with sets that contain the letters in the alphabet, then the universal set contains all the letters in our alphabet. If we're dealing with a set that contains people that live on planet Earth, then the universal set would be the set that contains all the people that live on planet Earth. Okay, it's contextual. Okay, it depends on the circumstance you're working in, how you think about the universal set. And we just represent it by U. Okay? Okay. Get that idea? Universal set. Okay. So with those, and we can think about one set operation. We'll do this one, and then the next section we have a few more that we add on. But the thing we want to think about here is called finding the complement of a set. And the complement of a set is a set of all the elements that are not in the set. Okay? So it's kind of like the opposite of the set. And the notation that our textbook uses is this tick mark here. Okay. A tick mark there. Like a single quote. That unfortunately is not universal. Okay, there's several different notations that can be used for complement. Every time we use it in this class, we'll use the little tick mark, okay, just so we're consistent. But I'm not sure why our author picked that one. That's not by far not the most common. So sometimes you'll see A with looks like an exponent, a superscript C for complement. Or sometimes you'll see a bar over the top. That can mean complement. So just wanted to mention those to you. We'll always use the tick mark in here. Okay, so let's think about one real quick right here. Let's do an easy one. Well, the terrible bracket. Okay, so here's our universe. It's just the letters A, B, C. And if set A is just the letter A, then what would be in the set A complement? BC, everything that's not in A. So this one would be BC. Okay. Our idea there. And then one other little thing to point out, what if, let me just write it down. Okay. What if we wanted to find a complement? We wanted to take the complement of a complement. So we want the complement of this set. It would be A. It would be this set, so it would be A. So if you take the complement twice, it cancels itself out. Okay? You end up back with the original set. Okay. All right, let's look at a couple of examples. We'll head into the weekend. Okay. All right, our textbook's getting a little bit dated. Twitter's been around a long time, and on this example, it like explains what Twitter is to you, like it's this new thing you've never heard of before. And so, that's why our textbook's getting a little old. Okay, it says Twitter is a type of online social media where registered users can post tweets that are up to 140 characters long, and they're not even true anymore. It's going to be longer than that now. In the world of Twitter, you can keep up with what other users post by following them, and in turn, other users can follow you and your tweets. Okay? If you didn't know that, that's there. Okay? Your generation's past Twitter for the most part. Any of you use Twitter? Like just a little bit? Yeah. A few of you, yeah.
Twitter's a very toxic place.
Yeah, that's true too. Okay, it's just the internet in general. Okay, so let's look at our setup here. Our universal set, the set of, how do we read this? This is a set of all x's such that x is a registered user on Twitter. So these are all the people that are registered users on Twitter. Okay, set A is the set of all x's such that x is a registered user on Twitter and x follows you on Twitter. So this is the set of all people that follow you on Twitter. Okay. And then we've got one more set on the next slide. Okay. We've got set B. It's the set of registered users on Twitter and you do not follow them on Twitter. So set B is the set of all people that you do not follow on Twitter. Okay. We want to find the complement of both of these sets. So let's find a complement first. So I'll flip back to A. Okay, so A is all the Twitter users that follow us on Twitter. So the complement would be what? All the ones that don't follow us, okay, on Twitter. Okay? A complement, I'm not going to write down is a registered user of Twitter. Again, I'm just going to say it's a set of x's such that x does not follow us. Okay? And then for B complement, so B, the set of all the people that we do not follow. So B complement would be the set of people that what? We do follow. So B would be the set of all the Twitter users such that we do follow them. And let's see. See? That make sense? One more example for us and then we'll be done. We don't care about all that, okay. All right, let's look at this. So here, our universal set is this a set of x's such that x is a book published in the United States in 2014. So the set of all books published in the US in 2014. And our set A says it's the set of x's such that x is a member of you. So that's a short way of saying x is a book published in the US in 2014 and you read x as an ebook. Okay. And it says find a complement. Yeah, so A is a set of the books published in the US in 2014 that we read as an ebook. So a complement would be those books that we did not read as an ebook. Okay? So again, we'll say it's one of these books published in the US in 2014 and we did not read as an ebook. That's a complement. And then it asked us another question. It said, is it possible that we read a book that's an A complement? Yeah. Yeah, as long as we didn't read it as an ebook, right? We could have read it just a regular paper book, right? The hard copy. Okay, so it's not the ones we didn't read at all, it's just the ones we didn't read as an ebook. Okay. Questions on that one? Oh, okay. You glad it's Friday? I needed today to be Friday when I woke up, so that's good. Okay. All right. If you didn't get on the sign-in sheet, make sure. Well, I'll find out where it's at. Make sure you get on there before you leave today. Okay. And I will see you Monday. Have a good weekend.
Where's the sign?
It's over here, back here. Thank you. Get in there. You need it. It did get stuck. We were so spread out today, it might not have made its way all the way around.
Sign-in sheet.
I put it over there on the table right there.